To learn about how to predict the products for single replacement reactions. Now, I know I've already written a lot of information here on the screen, so please feel free to pause the video if you need to jot these things down, and then come back to it to hear the explanation. For single replacement reactions, we can identify them by recognizing that their reactants are going to be one element and one compound. Now, I think personally that predicting the products of a single replacement reaction is the trickiest of all of them because it is the most conditional. Depending upon what the element reactant is ultimately going to determine how the reaction proceeds. So I've written two conditional statements here. What to do if the element is a metal and what to do if the element is a halogen, namely these four here, fluorine through iodine. If the element is a metal, then what it's going to do is kick the metal or replace the metal in the compound. It's going to take the metal in the compound and kick it out. In other words, the positive ions or the metals are going to trade places. Now, if the element is a halogen, again, particularly these four, then it can replace the halogen that's in the compound. Or in other words, the negative ions trade places with each other, or the negative ions get replaced. In every single case, though, it is extraordinarily important to recognize that the element and compound that you're going to make, one, the element may be diatomic, it may not be. We have to be mindful of that, but we can always be confident that the compound that we're going to write is going to be ionically bonded. So regardless of whether or not it's the element getting or the metal getting replaced or the halogen getting replaced, the compound that you're going to write the product for, or the compound that you're going to write as a product, is going to be ionically bonded. And it is imperative that we write its formula correctly in order to balance it. So I've written two different examples here on the screen, one in which the metal is going to get kicked out and the other in which the halogen is going to get kicked out or replaced. In our first example here, we have the element sodium reacting with the compound potassium oxide. In this case, the element here is a metal, sodium. So what that means is that sodium can swoop in here and kick potassium out. Where sodium is currently by itself and potassium is bonded to the oxygen, the opposite should be true on the product side. So what I recommend doing whenever you're writing these products is to again consider the ions in question. Sodium is going to have a 1 plus charge as well as potassium. Oxygen is going to have a 2 minus charge. And personally, I recommend writing them out. I think it helps to see exactly what's happening here. Currently, the potassium is what's bonded to the oxygen, but again, the opposite should be true on the product side. So basically, sodium and potassium trade places with one another. It's important to remember that the positives never, ever, ever bond together. They just trade places. So that means sodium is going to bond with oxygen, and poor old potassium is going to get kicked out all by itself. Potassium is not diatomic, so we can just write it as K. And once we've done that, we've quite literally taken it out of the equation. The only two things left to go together are the sodium and oxygen ions here, and to remember to crisscross their charges to get the correct formula of Na2O. So again, with this one, it's important to remember or notice that when the element is a metal, it replaces the metal in the compound. Sodium was by itself and potassium was bonded. Now potassium is by itself and sodium is bonded. Again, this is not going to give us a reaction that's balanced, or it's very unlikely that this is going to give us a reaction that's balanced. So it is important that after we correctly predict the products of the reaction, we go back and balance it. Now, in our next example down here, I've written things a little bit differently. I say here that the reactants are one element and one compound, but it can also be one compound and one element. The order doesn't really matter all that much. So in this case, though, we still have to pay attention to what the element is. In this case, our element here is fluorine, which is a halogen. So what that means is that fluorine is going to swoop in here and replace the halogen that's in the compound. So that means poor old chlorine here is going to get the boot. Still, to predict the products of the reaction, I think it is very important that we consider the charges of the ions that are going together here. Calcium is a 2 plus, chlorine a 1 minus, and fluorine a 1 minus. Now, just like in this previous example here where we said the positive ions are most definitely not allowed to bond to one another, the same is true down here, but in terms of the negatives. Your negative ions will not bond to each other. Chlorine is not going to attach to fluorine. Chlorine is getting kicked out by fluorine. So where fluorine is by itself and chlorine is currently bonded, the opposite should be true on the product side. So what that means is that poor old chlorine here is going to be by itself. It gets a 2 here because chlorine is one of those diatomic elements. So if chlorine is going to be all by itself, that leaves calcium and fluorine to bond together to make CaF2. Again, I'm getting this here from crisscrossing the charges, calcium at a 2 plus and fluorine at a 1 minus. Now in this case, we do get pretty lucky here because this does give us a reaction that's already balanced. Still, I think it's extremely important that even if we recognize it's balanced, we still fill in the blanks with the ones here. So again, these tend to be a little bit trickier to predict the products for because we have to be very careful about what the element actually is. As it says here, if the element's a metal, then it replaces the metal that's in the compound and forms an ionically bonded product. The element that was by itself is going to be bonded, and the element that was bonded is going to be by itself. Similarly here, if the element is a halogen, then it replaces the halogen that's in the compound. If one halogen starts out as bonded, it should be by itself as a product. And whatever halogen starts out by itself should be in the compound at the end.